Okay, so now we have to find the acceleration. To find the acceleration, first we took 4 time trials and we averaged them out to get, so since we have the time, we just use the change in x equation. Change in x equals v0t plus 1/2 a t squared. We know that our change in x is 1 meter and our v0t is 0. And our time is 1.68 square. And once you calculate this, you get 1 equals 1.4112. You divide 1 by 1.4112. And A equals 0.709 meters per second squared.
After we found the acceleration, we drew a free body diagram of the forces acting on the book. So this was the normal force acting on a book, and then this was the friction. This was the force of gravity, also known as mg, and we found the force parallel and force perpendicular.
How we do that, so you make a triangle. We know that this side is 1.155, and we know that this side is 0.38. We're solving for that angle. So in order to find our angle, we have to do sine inverse of opposite over hypotenuse. So in order to do that, we do sine inverse of 0.38 over 1.155, and for theta we get 19.21 degrees.
Please excuse the interruption, but since physics is life, you gotta stay hydrated to do these physics problems.
So now that we have acceleration and our angle, we can solve for mu. by knowing these two fundamental equations. Our net force is equal to mg sine of theta, which counteracts friction. From there we know that friction is actually equal to mu times n. And we know that net force is equal to mass times acceleration. So we can then fill in the things that we know. Still, we do not know the mass. We know gravity is 9.8 meters per second squared times sine of our angle, which is 19.21, minus mu, which is what we're solving for, times our normal force, which we know is counteracting mg cosine of theta. Which is all equal to mass times our acceleration, which is 0.709. From that, we have a common variable which we can cancel out, m. And we're left with 9.8 times sine of 19.21 minus mu, which is what we're solving for now, and our only unknown, times 9.8 cosine of 19.21, which is equal to our acceleration, which is 0.709. Once you solve and subtract this amount from here, you're left with mu, negative mu times 9. We're left with negative mu times 9.25, which is equal to negative 2.511. When you divide by both sides of negative 9.25, you're left with mu is equal to 0.271. And there are no units for mu.
So we increased the level of the round, and we changed the n. And we know mu doesn't change, so we should have got the same mu. Our previous mu was 0.281. The mu we calculated for our new angle was 0.271. This is pretty much accurate, but we know that we know the numbers would be different due to human error. And examples of the human error are the reaction time. There's an uncertainty in the reaction time because we're humans, we make mistakes. And when you square it, it makes even more of an uncertainty of the time. And the measurements, we don't know if we were starting the book at the same measurement. We don't know if we were starting the book at 1 meter each time we took this experiment. WWWDD. What would we do different? So if we were to do this experiment again, we'd have a sensor because a sensor would be more accurate. A sensor would tell us when we have reached a point at which the book has stopped moving.
We're out here live in the 4th floor annex trying to figure out if we change the slope of this board, if the coefficient of friction will change. Do you think that if we change the slope of that board, that the coefficient of friction will be bigger? Yeah, either. Like, do you think it will change? Yes.
Oh. No, I don't think
You don't think?
No.
Do you think that if we change the slope of that board right there, that the coefficient of friction will get bigger?
Yeah, because the normal force will change.
Do you think
Wait, will it impact the coefficient of friction?
Yes.
Or are you asking me
Will
if
it
the coefficient
impact-
of friction will get bigger?
Will it
impact
impact the
it?
coefficient of friction?
No.
I don't know what coefficient of friction is. No.
Yes.
Thank you.
Our findings, we see that most people do think that the slope will affect the coefficient of friction. And that's all.